Hi guys, today's Wednesday, April 26th. You need to have out your review from yesterday, your reported category 2 review. Okay, we're going to start where we left off yesterday. So the chart says you're going to identify each of these as speed, velocity, or acceleration. The first one, a roller coaster slows as it travels up a hill. That's acceleration. A cyclist travels 40 kilometers in 2 hours. That's speed. A flock of geese flies north at 55 miles per hour, velocity. A race car makes a slight left turn while maintaining the same speed, that's acceleration. An athlete can run about 12.5 kilometers per hour, that's speed. A car travels 2.5 hours in a northerly direction for 300 kilometers. Determine the car's speed and velocity. So to show your work for this problem, you got speed equals distance divided by time. So you take the distance, which is 300 kilometers, divided by the time, 2.5 hours. And for your speed, you should get 120 kilometers per hour. And then your velocity is 120 kilometers per hour north, because velocity has a direction with it. The next one says, study the diagram below. A student rides a bike 2 hours from school to home, making stops along the way. What is the average speed that the student is traveling? So to find average speed, you take the distance divided by the time. You have to find the total distance. So he went 4 kilometers here, 3 kilometers here, and 2 kilometers here. You add all of that up, you get 9 kilometers. And it tells you that he took 2 hours. So his speed is 4.5 kilometers per hour. And then last one, did the student accelerate during the ride home? He did accelerate because he changed direction. The next page is on Newton's laws. These are the easy ones. So Newton had 3 laws. You fill in the blanks for which law is which. The first one, Newton's blank law of motion, states for every action there's an equal and opposite reaction. Forces come in pairs. It is often referred to as a law of action and reaction. That's the third law. Second one, Newton's blank law of motion states that an object at rest will stay at rest, and an object in motion will stay in motion at the same speed and in the same direction unless acted upon by an unbalanced force. It's sometimes called the law of inertia. That's the first law. Then the third one, Newton's blank law of motion states that an object acted upon by an unbalanced force will accelerate in the direction of that force in direct proportion to the strength of the force, and in an inverse proportion to the mass of the object. It's called the law of force and acceleration. That's when we use the formula F equals ma. That's Newton's second law. Define inertia and give an example. So inertia is the tendency of an object or a body that is in motion to stay in motion. If it's not in motion, then it's going to remain at rest. So an example would be in your car. If you slam on the brakes, your body is going to want to continue forward because you are not braking, the car is braking. So your seatbelt, that's why your seat belts are there to prevent the inertia of your body from going forward. Here, the first picture is showing two people lifting weights, and one of them has more mass on the bar. So that's the second law of motion. The second picture is a person stepping off a boat onto a dock. That's showing action and reaction. So as she steps off of the boat is going to go backwards and she's going to go forward. So that's action and reaction. The third one is a picture of a squid, and it's showing the direction of movement, and it's showing water going out because of its tentacles. That's action and reaction. And then the last one is a golf ball sitting on a tee. As long as the golf ball sits on the tee, it's not acted upon by any other outside force. So a club going by and hitting the tee, it's going to stay there. So that's the first law of inertia. The next page, if a team pulls with a combined force of 9,000 newtons on an airplane with a mass of 30,000 kilograms, what is the acceleration of the airplane in meters per second? Record your answer in the grid below. So for this one, we're going to use the triangle because we have to manipulate the formula. So the formula is force equals mass times acceleration. So we're going to plug it into the triangle. We're solving for acceleration. So we're going to cover up the A, and our formula becomes force divided by mass. So the force that it gives us is 9,000 newtons. The mass is 30,000 kilograms. And when you divide, your answer should be 0.3 meters per second squared for the acceleration. The shopping carts shown above are pushed down the hallway with the same amount of force. Which cart has the greatest change in speed? Circle the cart above and explain your answer below. So the cart we're going to circle is this one. The reason being is that it has the smallest mass. So if you have the smallest mass and you're pushing with the same amount of force, that one is going to have the greatest change in speed or the greatest acceleration. The next section is talking about work. In science, for work to be performed, a force must be used to move an object. Regardless of how much force is being used, if no movement occurs, no work is done. The formula for work is force times distance. Work is measured in joules, Joules, and it'll be a capital J. The man in the picture is pushing against the beach ball with 20 newtons of force. The ball does not move. How much work is being done? Show all of your work. So for your formula, work equals force times distance. The force is 20 newtons. His distance is 0 meters. So no work is being done because he's not moving the object. Next page says, use the information and diagrams below to answer the two questions that follow. A student needs to lift a heavy ball up onto a table that is 2 meters high. She uses 6 newtons of force to raise the ball straight up. That's example number 1. But only 3 newtons of force is required to roll the ball up the ramp from example number 2. Calculate the amount of work done for each example above. Show all of your work. So for your first example, work equals force times distance. Your force is 6 newtons times 2 meters, so that gives you 12 joules of work. Second example, work equals force times distance. So your force this time is 3 newtons, and you're moving this one 4 meters. So your work is also 12 joules. You're doing the same amount of work, you're just doing it in different ways with different amounts of force. Does the amount of work change in the two examples? Explain. No, you're doing the same amount of work, but the amount of force that you put into the object is changing. That is how you're doing the same amount of work, but you're doing it differently. Which of the following results in the least amount of work being done? So for these, you multiply the force times the distance, and the one that has the least amount of work, it should be letter A. Okay, potential and kinetic energy. This is way back from 6th grade. Fill in the data table to the right to correctly classify the activities of the children in this picture as either kinetic or potential energy. So the girl jumping a rope, she's moving, so it's kinetic. The boy standing with a soccer ball, he's not moving, so it's potential. The kite flying in the wind, that's kinetic, it's moving. The boy balancing on his head, he's not moving, so that's potential. And the bee buzzing around the boy's head, he's moving, so it's kinetic. At which point does the water in the waterfall to the left have the greatest gravitational potential energy? Circle your answer in the picture. So for the greatest gravitational potential energy, you want the one that's highest off the ground. So that's number 1. Use the diagram of the roller coaster above to fill in the missing information. A, as a roller coaster moves from point Z to point Y, the potential energy blank as the kinetic energy blank. So the potential energy decreases as the kinetic energy increases. As a roller coaster moves from point Y to point X, the potential energy is going to increase as the kinetic energy decreases. At which of the 4 points does the cart have the least potential energy? You're looking for the one that is lowest, so that's point W. A diagram of a pendulum is shown to the left. A pendulum is released from position 1. At which 2 positions will the pendulum's potential energy equal its kinetic energy? It should be B, positions 2 and positions 4. Remember that kinetic and potential energy are going to flip-flop as you go back and forth. Blank is energy that is stored and available to be used later. That's potential. Blank is energy that an object has because of its motion. That's kinetic. Okay, speed. If an object travels 42 meters in 6 seconds, what is the average speed? Speed is distance divided by time. So the distance is 42 meters. The time is 6 seconds. When you divide, you should have gotten B, 7 meters per second. What is the difference in average speed between 2 cars, one that has traveled 150 kilometers in 5 hours and the other that traveled 130 kilometers in the same time? Record and bubble in your answer below. Show all of your work. So you've got 2 calculations here. The first one traveled 150 kilometers in 5 hours. 150 divided by 5. So you should have gotten 30 kilometers per hour. The second one, he traveled, distance divided by time, 130 in 5 hours. So this one's speed is 26 kilometers per hour. So if you subtract, because it's asking you to find the difference, if you subtract, you should have gotten 4 kilometers per hour. Graphing speed and graphing motion. In the graph to the right, how many kilometers has the object moved after 10 minutes? So with this one, you go over to time 10, and you go up, and its distance is 1.5 kilometers. In the graph to the right, how many kilometers has the object moved after 20 minutes? So go over to time 20. and should have been 1.5 kilometers again. In the graph to the right, how many minutes did it take the object to move 3.5 kilometers? So this one you go up to distance 3.5, then you go over, and it took 40 minutes. Which of the following situations could be represented by this graph? It should be C. Which graph shows the fastest speed? You're looking for the one that has the steepest line. That's going to be D. The graph below shows the speed of a car traveling north over a 16-second time period. Based on the information in the graph, it can be concluded that in the first 8 seconds, the car is... So with this one, you've got to look at your axes. You've got speed and you've got time. So because you've got speed and time and the line is going straight here, it's B, accelerating at a constant rate. Identify each of the 7 forms of energy represented below. Label them using the following terms. So it gives us a word bank here. The first one, a campfire, is thermal. The sun is light. Food, any kind of food, is chemical. Next one is electrical. Next one is sound. The next one is nuclear, showing a power plant. Then electrical. Then nuclear again. The next two are both mechanical. And the last one is chemical. Oil, you got to burn it, so it's chemical. The next page, blank states that energy cannot be created or destroyed, but only transformed into different forms. That's the law of conservation of energy. Complete the chart using these types of energy: mechanical, thermal, electrical, light, sound, and chemical. So you're doing energy transformations. You got to figure out what it's starting out as and then what it's being converted to. So a hairdryer is going to start out as electrical and it's converted to, you could say mechanical because it's got a fan. Then you could say thermal for heat, and you could also say sound. A battery-operated radio, so it's got batteries. It's going to start out as chemical, and then it's going to go to electrical and sound. A glow stick is going to start out as chemical, and it's going to create light. A piano is going to be mechanical, and it's going to go to sound. A plant going through photosynthesis is going to start out as light and it's going to go to chemical. A roller coaster is going to start out as mechanical, and because of friction, it's going to create heat, which would be thermal. And then a flashlight. Flashlights work off of batteries, so it's going to start out as chemical, and it's going to go to electrical, light, and probably thermal. It's going to release a little bit of heat. Okay, these are the problems that were on your release STAR test that I'd like you to go back and review. If y'all need to pause the video here so everybody can write down these problems, or go and circle them, or you could write them on the front of your review booklet for this category. I'd like you to go back and review these. Again, look at why you got them wrong, if you got them wrong, and what you did. Maybe you read the question incorrectly, maybe you looked at the diagram wrong. So just double check these and see how you did on these problems. Again, keep your review in your binder. It should already be hole punched for you. Hold on to this review because you're going to turn it in after we finish all 4 of these review packets.